In this question, you can see that there is a ramp of height h and this is a building of height 3h. This ramp is frictionless and this ball is released from the top of the ramp, and when it leaves the contact with the ramp, then its velocity is u naught in the horizontal direction. It strikes the ground at a distance d at an angle of theta, and it rebounds with velocity v, and then after rebound it attains a maximum height of h from the ground. So the coefficient of restitution is 1 by root 3. So we have to find out the correct options. First of all, we can see that this ball is released from rest from top. So we can say that u naught will be equal to, I can write it here, that u naught is equal to root 2gh. This we can easily say, and therefore the first option is correct, that u naught is equal to root 2gh I cap. Then you can see that the second option is wrong, because this velocity v is pointing towards first quadrant, and therefore x and z directions would be positive. So this is not correct, and this angle theta. So when this ball will strike the ground, then the velocity of the ball in y direction would be under root 2g into 3h, which is 6gh, and in x direction it would be under root 2gh. So the angle, this angle theta, so tan theta would be equal to under root 6gh upon under root 2gh. So theta would be equal to 60 degree. Okay, now this angle theta is 60 degree, and this range d would be equal to this velocity u naught into time of flight, and time of flight would be under root 2h by g, where h is 3h, so it is 6h by g, where u naught, we know that u naught is under root 2gh, so this is under root 2gh into under root 6h by g. So d will be equal to 2 root 3h. Okay, now we know that after collision from the ground, when the ball will rebound, its velocity in the y direction would be vy dash, and vy dash would be vy into e, where e is 1 by root 3. Okay, so vy is this one. So vy dash will be equal to this is under root 6gh divided by root 3. So vy dash would be equal to root 2gh. Okay, so this is vy dash, and the maximum height attained by the ball will be vy dash square by 2g. So h1 will be equal to this is 2gh by 2g, and therefore it would be h. So h1 is equal to h, and hence we can say that d will be equal to 2 root 3 of h1, and d by h1 will be equal to 2 root 3. So the correct answer will be A, C and D. Now we move on the next question. In this question, you can see that this is a prism, and a plain polarized blue colored light is incident on this prism. There is no reflection of light from this prism surface, and all the light enters the prism, which means that this angle of incidence would be the Brewster angle. Okay, we have already studied the Brewster angle. Now it is given that the refractive index of this material of prism for blue light is root 3, and we know that the angle of polarization, polarizing angle, is tan inverse mu, which is Brewster angle, and we know that mu is root 3. So IP would be equal to tan inverse root 3, and therefore IP is equal to 60 degree. Okay, now the deviation of this light for this prism is 60 degree. So del is 60 degree. So 60 will be equal to I plus E minus A. Okay, so I is also 60. So we can say that 60 is equal to 60 plus E minus A, which means that E will be equal to A. Now we know that the angle of refraction is 1 sine 60, and it would be equal to root 3 sine R1. So R1 will be sine 60 is root 3 by 2, and you can see that R1 would be 30 degree. Okay, and R2 would be A minus 30. And therefore we can say we can apply the Snell's law on the second surface. So it would be root 3 sine R2, and that would be equal to 1 sine E, and E is equal to A. Sorry. Now you can see that R2 is A minus 30, so root 3 sine A minus 30 will be equal to sine A, and we can open this with sine A minus B formula. So it would be sine A cos 30, which is root 3 by 2, minus cos A sine 30, which is 1 by 2, and it is equal to sine A. So you can see that this is 3 by 2 sine A minus root 3 by 2 cos A is equal to sine A, and sine A by 2 is equal to root 3 by 2 cos A. So you can see that tan A is equal to root 3, and A is hence equal to 60 degree. Okay, now the first option is the fact that blue light is polarized in the plane of incidence. We know that if the light is incident at Brewster angle, then all the vibrations which are parallel to the plane of incidence are reflected back. But there is no reflected light in this case, which means that all the vibrations are perpendicular to the plane of incidence. So the plane in which vibrations are occurring is perpendicular to the plane of incidence, and therefore the plane of polarization is parallel to the plane of incidence. Okay, so we can say that option A is correct. Prism angle is 45 degree, which is wrong. So option B is wrong. And option C, that the refractive index of the material of prism for the red light is 60 degree. Let us see that for red light, del minimum is given as 30 degree. So when del is minimum, then we know that I is equal to E, and R1 is equal to R2, and it is equal to A by 2, and del minimum is also equal to 2I minus A. So 2I minus A, del minimum is 30, and this is 2I minus A. Prism is same, so A would be 60 degree, therefore I would be equal to 45. Which means that this angle of incidence is 45 degree for this one, and angle of emergence will also be equal to 45 degree because I is equal to E for this. Now we see that if E is equal to A and A is 60, then the exit angle for blue light is also 60. So D is also correct answer. And now we will discuss the refractive index of this prism for red light. So we can say that A is equal to 60, and therefore R1, R2 are equal for minimum deviation, and they are A by 2. So this is 30. So let us apply the Snell's law on the first surface, that 1 sine 45 for red light is equal to mu sine 30. So you can see that mu is root 2. So option C is also correct. So the correct answers are A, C and D. Okay, now we move on the next question. In this question, let us see that there is a capacitor whose capacitance is 2 microfarad, and this is uncharged initially and this K was open. In this condition, 1 ampere current flows through this resistance and this key is closed at time t equal to 0. So first of all, we have to check the value of R. So let us suppose that 1 ampere current is flowing like that. Okay, so if this 1 ampere current is flowing in this direction, then this battery would be charging. This battery would be in the state of charging. So let us name this point as A and this point as B. So we can say that VA minus VB will be equal to E plus IR, and E is 5 and I is 1 and R is 1. So this is 6. So this is 6 and therefore this voltage would also be 6 and a current I1 would be 2 ampere. Okay, so B option is correct, that before closing the key this current was 2 ampere. Now this is 1 ampere and this is 2 ampere, so the current flowing through this cell would be 3 ampere, and obviously this is in a discharging mode, so we can say that VA minus VB for this cell, which is VA minus VB for this cell, will be E minus IR. Now VA minus VB is 6 and E is 15 and I is 3 and this is R. So you can see that 3R is equal to 9 and R will be equal to 3. So option A is also the correct one. Now after closing the switch, we have to check the steady state condition first. So at t equal to infinity. So let us draw the diagram when t is equal to infinity. So when t is equal to infinity, then no current would be flowing through this capacitor, and hence the situation would be same like that. So if no current is flowing through this capacitor, then the voltage across this capacitor would be 6 and voltage across this resistor would be 0. So the charge stored in this capacitor would be CV. So Q will be equal to 6 into 2. So this is correct. And the C option, that at time t is equal to t0 plus 7.2 microseconds, the current flowing in the capacitor is 0.6 ampere. So let us examine this. We know that the value of RC. So let us find out the value of RC. To find out the value of RC, we know that we have to short circuit all the cells. The value of R is 3 ohms, and this is 1 ohm, this is 3 ohm, and we have to open the capacitor and we have to find out the R equivalent. So you can see that 3 and 3 are in parallel to each other, and in fact this 3 and this 3 is in parallel to each other, so it would be 3 by 2 and 3 by 2 and 1 is also in parallel to each other, so the combination would be 3 by 5, and 3 by 5 and 3 are in series with each other, so 3 by 5 plus 3 is 18 by 5. So R equivalent is 18 by 5, and therefore RC, which is the time constant, so R equivalent into C would be 18 by 5 into C, which is 2 in microseconds. So this would be microseconds. So it is 36 by 5 microseconds. This is that equivalent time constant. Now we know that in this case, let us see that in this case the charge, the current flowing through the capacitor. We have to find out the current flowing through the capacitor, and we know that the current equation is I is equal to I naught e to the power minus t by RC. We know that in the charging RC circuit, the current is decaying, and therefore the equation would be like that. And the value of I naught is equal to Q, which is CE, divided by, which is the maximum charge, divided by time constant. So maximum charge was 12 micro coulomb and the time constant was 36 by 5. So the I naught is equal to 5 by 3. So we can say that I will be equal to 5 by 3 e to the power minus t, which is time. So we can see that the time would be 7.2 microseconds. So this is 7.2 divided by RC. So RC is also equal to 7.2. Time constant is equal to 36 by 5. So 36 by 5 is 7.2. So I is equal to 5 by 3 into 1 by E. So we know that E inverse is 0.36. So this would be, I would be equal to 5 by 3 into 0.36. So this would be 0.6 ampere. So the current flowing in the capacitor at this time would be 0.6 ampere. So the correct options are A, B, C and D. Now we move on the next question. In this question you can see that there is a bar of mass 1 kg. This is, let us write down the variables. So mass of the bar is 1 kg m, its length is L, so this is L, and another mass which is small m is coming on a frictionless surface, on horizontal surface on which this rod is kept. This rod is pivoted from this end and this mass strikes the rod with velocity u, and after striking, u is given as 5 and it hits at a distance of L by 2 from the pivot and returns back on the same path with the speed of v. Okay, so after collision it returns back with v. So we have to find out omega of the rod and v. So we all know that in the case of pivot we have to balance the angular momentum, and it is also given that collision is elastic. So first of all, let us write down the equation of angular momentum. So the initial angular momentum was mu L by 2 and final angular momentum of the rod, let's suppose that rod starts to rotate with the angular velocity of omega. So the final angular momentum of the rod would be I omega in the anti-clockwise sense, and initial angular momentum was also in anti-clockwise sense. And when the ball starts to return with velocity v, then we can say that the angular momentum of the ball would be mvl by 2. So the minus mvl by 2, because this angular momentum would be in the clockwise sense. Now this is the first equation, and we know that the variables in this equation is v and omega. Now we need to find out omega and we need to replace v. So the equation, the collision is elastic, so E is equal to 1. So we can say that if E is 1, then the relative velocity of this point and the ball after collision. So you can see that this point would be moving with velocity L by 2 omega in this direction, and ball is moving away from the rod. So the relative velocity would be L by 2 omega plus v, and the initial relative velocity would be u. So V will be equal to U minus L omega by 2. So we can replace this V and we can substitute the value of V here. So M U L by 2 is equal to I omega, where I is M L square by 3 into omega minus M V, and we can replace V with U minus L omega by 2, and this is L divided by 2. So you can see that this is minus mu L by 2 and this is mu L by 2. So we can add up these two. So it would be MUL and it is equal to ML square by 3 minus this is plus ML square omega by, in fact we have taken omega as common. So this is M L square omega by 4. So this is M L square omega by 4. Okay, and omega is common. So the value of omega would be MUL divided by ML square by 3 plus ML square by 4. This is the value of omega. Okay, now let us substitute the values. So we know that the value of this mass, small m, is 0.1 and capital M is 1 kg. So this is 0.1. In fact, we can write it as 10 to the power minus 1. And the value of U was 5 and the value of L was 0.2. So this is 2 into 10 raised to power minus 1 divided by M, which is 1, and L square is 4 into 10 to the power minus 2 divided by 3 plus small m is 0.1. So this is 10 to the power minus 1 and this is L square and it is 4 into 10 raised to power minus 2 divided by 4. Okay, so it would be equal to omega. So this is 10 and this is 10 to the power minus 1. So only 10 to the power minus 1 is left in the numerator, and in the denominator we can say that if we take out 4 into 10 raised to power minus 2 common, then in the denominator it would be 1 by 3 plus this would be 1 by 40. Okay, so the LCM would be, this is 1 by 4 into 10 raised to power 1, and in the denominator it would be 120 and it would be 40 plus 3. So finally it would be 120 by 4, which is equal to 30, and this is 300 divided by 43. So 300 divided by 43 is approximately 6.97. So the correct answer would be A, in which omega is 6.98. We do not need to calculate V, and if you wish to calculate V, you can substitute the value of omega here. Now we move on the next question. In this question, you can see that there is a capacitor as shown in the figure, and this capacitor is being continuously filled with the liquid. So this liquid has a dielectric constant of 3. In fact, I guess the dielectric constant of this liquid is 3, yes, and it is filled with a constant rate of 250. Now we have to find out the value of capacitance at after 10 seconds. So first of all, let us see that the rate at which liquid is filled is 250. So 250 is equal to the area of the cross section in which liquid is filling. So the area of cross section would be 50 into 5. So this is 50 into 5 and v is the velocity. I have used rate of flow q is equal to a1 v1 av. So you can see that v is equal to 1 centimeter per second. Okay, now after 10 seconds, at t is equal to 10 seconds, the height of dielectric would be 10 centimeters, and therefore let's suppose this is the height and this is 10 centimeters, and therefore the remaining height would be 40. So there would be two capacitance, this would be C1 and this would be C2. So the value of C1 would be epsilon naught A. Now the area of this one would be 40 into 50 and into 10 raised to power minus 4 because these both are in centimeters, and divided by the d, which is 5 into 10 raised to power minus 2. Okay, so C1 would be epsilon naught into, this is 20 and divided by 5. So C1 would be 4 epsilon naught. Okay, now the second capacitance, this C2, would be epsilon naught into epsilon r, which is 3. The area of each plate would be 10 into 40 into 10 raised to power minus 2 divided by 5 into 10 raised to power minus 2. Okay, so this is minus 4 in fact. Okay, so this would be, you can see that C2 would be equal to 3 into 4 divided by 5, which is 12 by 5 epsilon naught. So this is 12 epsilon naught by 5. Now these two capacitance are in parallel, so C equivalent would be C1 plus C2. So C1 plus C2 would be equal to C2 would be equal to epsilon naught into 3 into area would be 10 into 50 into 10 raised to power minus 4 divided by 5 into 10 raised to power minus 2. So C2 would be 3 epsilon naught. And these two are in parallel, so C1 plus C2 will be equal to 7 epsilon naught, and epsilon naught is this. So C equivalent would be 63 picofarads. So the correct answer would be B. Now we move on the next question. In this question, you can see that 1 mole of an ideal gas expands adiabatically from Ta V0 state to Tf 5 V0 state, and another single mole of the same gas expands isothermally from this state to this state. So we have to find out Ta by Tb. So first of all, in the adiabatic process, we know that in adiabatic process T V to the power gamma minus 1 is equal to constant, and hence Ta V0 to the power gamma minus 1 is equal to Tf into 5 V0 to the power gamma minus 1. So you can see that Ta is equal to Tf into 5 to the power gamma minus 1. And in the second process, it is isothermal process, so temperature would be same. So Tb would be equal to Tf. So Tb would be equal to Tf. So if we divide these two, then Ta by Tb would be equal to 5 to the power gamma minus 1. So the correct answer would be option A. Now we move on the next question. In this question, you can see that there are two satellites P and Q which are revolving around the Earth in a circular orbits of different radius. The height of first orbit is r by 3 from the Earth's surface, and the height of second orbit is hq. Now it is given that the ratio of acceleration due to gravity gp and gq is 36/25. We know that g is equal to gm by r plus h whole square. So gp by gq will be equal to r plus hq whole square upon r plus hp whole square. Okay, so this is r and hq is unknown, and hp is equal to r by 3, so this is r plus r by 3, and gp by gq is 36/25. So r plus hq upon this is 4r by 3 is equal to 6/5, and you can see that this is 5r plus 5hq will be equal to this is 8r. So 3r will be equal to 5hq, so hq will be 3r by 5. So the correct answer is A. Now we move on the next question. In this question, you can see that there is a hydrogen-like atom of atomic number Z, and photons are emitted in the electronic transition from level 4 to 3. These photons are used to perform photoelectric effect on a target metal, and the maximum kinetic energy of the ejected electron from that metal is 1.95. So we have to, and the threshold frequency, threshold wavelength of the target metal is also given as 310. So we have to find out the value of Z. So first of all, we can see that the transition is occurring from 4 to 3, and the work function phi naught would be hc by lambda naught. hc is 1240 eV nanometer, and this threshold wavelength is 310 nanometer. So this work function would be equal to 4 eV, and the kinetic energy maximum is 1.95 eV, and therefore the energy of photon would be phi naught plus k max. So energy of photon would be 5.95 eV. Okay, now this is E, and we know that these photons are emitted from an atom in the transition 4 to 3. So this would be 13.6 into z square into 1 by 9 minus 1 by 16, and this is 5.95 is 13.6 into z square into this is 16 minus 9 upon 16 into 9. Okay, so z square will be equal to 5.95 into 16 into 9 and divided by 13.6 into 16 minus 9, which is 7. Okay, so the value of z square will be 9 and z would be equal to 3. So the correct answer is 3. Now we move on the next question. In this question, you can see that this is a optical arrangement. It consists of 2 mirrors and concave mirrors and 1 lens. The first mirror has a radius of curvature of 20, and therefore its focal length would be 10, and the second mirror would have the focal length as 12, as its radius of curvature is 24. The focal length of the lens is given as 10, and this source is placed at just midway at a distance of 10 from each of them. Okay. Now we have to find out the distance between this mirror and the lens, so that at least one image coincides with this source. So you can see that the first image that would be formed from mirror M2 would cannot coincide at this point, because for the first image of M2 to coincide with the object, it is necessary that object must be placed at a distance of radius of curvature from this mirror, and this is 10 and radius of curvature is 24. So it is not possible that the first image of M2 will coincide with S. Now let us see that what happens when the image of this S, the second image of this mirror can coincide with S, as the rays after getting reflected from M2 will pass through this lens, and after getting reflected again from M1 will again pass through this lens and will be traced back to S. So this will be a case, but we are taking a simple one in which we are coinciding the first image of this M1 at this point. So we can see the ray diagram would be like that, because this is the focus of this lens, and therefore the rays would be going parallel to the principal axis, and hence the first image of this would be formed at this point, which is the radius of curvature. So radius of curvature would be 20. So this is 20, and this distance would be x minus 20. So this x minus 20 would be the object for this lens, and the image formed at this point, let us see that. See, you can clearly see that this if this is the object, then let us draw another diagram. Let us see that the object is now at a distance of x minus 10, in fact I think x minus 20 from this lens, and this object cannot have its image at a distance of 10 from this lens, because the focal length of this lens is 10, and for image to be formed at 10 behind the lens, it is necessary that rays should be coming from infinity. So this is not possible that these rays would be converging on this point. So let us see that the case would be like that this mirror, which has a focal length of 12 and this distance is 20, so we can see that if this is the case, that the image of this lens is somewhere at this point, and after reflection image is formed exactly at S. So for this mirror we can say that F is equal to minus 12 and V is equal to minus 10, because the image of this mirror should be at this point, which is at a distance of 10. So let us find out U. So using mirror formula, which is F1 upon F is equal to 1 upon V plus 1 upon U. So minus 1 upon 12 is equal to minus 1 upon 10 plus 1 upon U. So 1 upon U will be equal to 1 upon 10 minus 1 upon 12. So U, you can see that this is 60 and this is 6 minus 5. So U would be equal to plus 60. So U is plus 60, which means that this lens would be making the image at this distance of 60. So now for the lens, we can see that U is equal to, in fact let us find out the U, and afterwards we'll equate this U to x minus 20. So for lens, V is equal to this is 80, This is 20 plus 60, and focal length of lens is 10. So 1 upon f is equal to 1 upon v minus 1 upon u, and 1 upon 10 is equal to 1 upon v, which is 80 plus 80 minus 1 upon u. Okay, and u is obviously negative because the object of this lens is this one. So this would be plus. So 1 upon u would be equal to 1 upon 10 minus 1 upon 80. Okay, so 1 upon u would be equal to 8 minus 1, which is 7 by 80. So u would be equal to 80 by 7. Now if u is 80 by 7, then 80 by 7 would be equal to x minus 20. So this is x minus 20. So x would be equal to 80 by 7 plus 20. Okay, so x would be equal to, this is 80 by 7 plus 20, and I think, yeah, this is I guess 10, and this is 10, and this is also 10. Okay, so this would be 10, and hence it would be 10. So this would be 10, and x would be equal to 150 by 7. Okay, so x is 150 by 7, and if we compare it with this one, n by 7, then the value of n would be equal to 150. So the correct answer is 150, and there are two more cases which you can see, which we have already discussed. In those cases, the correct answer would be 220 and 80. Okay, so 80 and 220 is another correct answers. Now we move on the next question. In this question, there is an experiment of determination of focal length of a thin convex lens, and the distance of object from this lens is this one, and distance of its real image is this one. So we have to find out the percentage error in calculation of focal length of this lens. So we know that 1 upon f is equal to 1 upon v minus 1 upon u is the lens formula, and in this formula, if we substitute the sign conventions, then 1 upon f would be equal to 1 upon v, which is a real image, so v would be positive, so this is plus 1 upon v, and object is also real, so it would be negative, so plus 1 upon u. And now if we differentiate, then we can see that df by f square will be equal to minus dv by v square minus du by u square, and this is, so df by f into 100 would be equal to dv by v square plus du by u square into f into 100. Now dv is 0.2 and v is equal to, this is v, so v is 20 and this is 20 square, plus du is 0.1 and this is u, which is 10, and into 100 into f. Now f is 1 upon f is 1 upon 20 plus 1 upon 10, so f is equal to, this is 20 by 3. Okay, so if we multiply 100 inside, then it would be 20 by 20 square plus this is 10 square, and this would be 10 by 10 square, and F would be 20 by 3. So this is 1 by 20 plus 1 by 10, so it would be 3 by 20, and this is 20 by 3, so the percentage error is 1%. So the correct answer would be 1%. Now we move on the next question. In this question, you can see that there is a closed container which contains a homogeneous mixture of 2 moles of an ideal monatomic gas and 1 mole of an ideal diatomic gas, and where gamma is the ratio of their specific heats. Now, the gas mixture does a work done of 66 joule when it is heated at constant pressure. So we know that, first of all, CV mixture is N1 CV1 plus N2 CV2 upon N1 plus N2. Okay, so N1 is 2, and monatomic gas has a CV of 3R by 2, plus N2 is 1, and diatomic gas has CV of 5R by 2 divided by 3. So CV mixture would be this is 3 plus 5R by 2, so this is 11R by 6. This is CV mixture. Now the work done by the gas is 66 joules, and it is equal to N PdV. At constant pressure, work done is PdV, and it is NR dt. So NR dt is equal to 66, and we have to find out the change in internal energy delta U, which is NCV dt. So N is the total moles of the mixture, which is 3. CV is 11R by 6, and this is dt. So NR dt is 66. So this is 11 into 66 by 6. So it would be 121. So the correct answer would be 121. Now we move on the next question. In this question, there is a lamp which is at a height of 400 centimeters from the ground, and there is a man which has a height of 160 centimeters from the ground. The image of the head of the man, or we can say the shadow of the head of the man, is at this point, and let's suppose that this distance is x2 and this is x1. Now you can see that this angle and this angle is same, so we will write down tan theta from this triangle. So this length, you can see that it is 240, and tan theta will be equal to 240 divided by x1, and tan theta from the bigger triangle would be 400 divided by x2. So x2 would be equal to 5 by 3 of x1. Now we differentiate these two, and dx2 by dt is equal to 5 by 3 of dx1 by dt. This dx1 by dt is the rate at which this x1 is changing, and this would be equal to the speed of man, and speed of man is 60. So this is 5 by 3 into 60, and dx2 by dt will be equal to 100, and this would be the velocity of the shadow. Now we have to find out the relative velocity of shadow with respect to man. So V relative would be V shadow minus V man, and it would be 100 minus 60, and it would be 40. So the correct answer would be 40. Now we move on the next question. In this question, you can see that these are 2-point objects of masses 30 gram and 20 gram, and these are connected with a rigid massless rod of length 10 centimeters. This rod is suspended with a toroidal wire. This wire is connected to the rod at the center of mass of these two masses, and this system is performing small oscillations. The toroidal constant of the wire is this, and the angular frequency we have to find out. So first of all, we know that the angular frequency of this system omega will be under root of k by I. Okay, where I is the moment of inertia about this wire. Okay, k is the toroidal constant, and I can be written as mu into L square, where mu is the reduced mass and L is the length of the rod. So omega would be equal to under root k by mu L square, and we have to find out this omega. Now the value of toroidal constant is 1.2 into 10 raised to power minus 8, and mu is a reduced mass, so let us find out mu, which is 30 into 20 divided by 30 plus 20 into 10 raised to power minus 3 in kilogram. So mu would be 600 by 50 into 10 raised to power minus 3. So mu would be 12 into 10 raised to power minus 3, or we can write it as 1.2 into 10 raised to power minus 2. Okay, so this is 1.2 into 10 raised to power minus 2. This is mu, and L of the rod is 10 centimeter, which is 10 raised to power minus 2 because it is square. So you can see that omega will be equal to 10 raised to power. This is omega, and omega would be under root of 1 upon 10 to the power 4, and this is 1 upon 100. So 10 raised to power minus 2 is equal to n into 10 raised to power minus 3. So n is equal to 10. So the correct answer is 10. Now we move on the next question. In this question, we have to match the correct entry of radioactive decay processes with list 2. The strategy which I use in these kind of questions is selecting the option which has a different matching in all of the 4 options. You can see that S option has different matchings in all 4 options, and therefore we need to just select the correct option for S. So you can see that this is 91 and this is 88. So you can see that 228 and this is 228 and 224. So mass number only changes due to the alpha decay, and you can see that the change in mass number is 4. So one alpha particle would be emitted, and due to emission of one alpha particle, the atomic number decreases by 2, so it should be 89. But one beta plus particle would also be emitted. Therefore, the correct atomic number would be 88. So the correct matching for option S is 1. So we can say that the correct answer is A. Now we move on the next question. In this question, again, we will use that strategy to choose the correct option, and you can see that P is having same 3 option, 3 and 3 and 3 in 3 options. So this is quite obvious that P would be having a correct matching of 3. Now let us examine Q. So Q has different options 5, 4, 2 and 2. So Q says that temperature is 3000 Kelvin, and let us examine this 5. So this is the radiation at the peak emission wavelength can use to find the image of human bones. This is wrong, and let us examine this one, C option, Q, for Q. So for matching of Q to 4, let us see that the power emitted per unit area is 1/16th of the emitted by the black body at 6000 Kelvin. We know that the power is dependent on T to the power 4, and it has a temperature of 6000 and this is 3000. So this temperature is exactly half of this temperature. So if this is half temperature, then power emitted by this body would be 1 by 2 to the power 4, which is 16. So the correct matching of Q is 4. So we can say that the correct answer would be C. And let us also examine R. So you can see that R option says that 5000 Kelvin. So you should know that 5000 Kelvin is the radiation at peak wavelength which is visible to the human eye. Okay, so the correct answer would be C. Now let's move on to the next question. In this question, there is a LCR circuit which is connected to this source, and resonance angular frequency is this. So first of all, L is given as 50 millihenry. So L is 50 into 10 raised to power minus 3, and omega resonance is 10 raised to power 5. Omega resonance is 1 upon under root LC, and we can find out C. So C would be 2 into 10 raised to power minus 9 farad. Okay, now we know that I naught is the amplitude of current when there is a resonance situation, and in resonance I naught is V naught by R, and otherwise at some other frequency it is given that I naught is 0.05 I naught, and that is V naught by Z. So this is we can conclude that Z is 20 R from these two. Okay, now XL is omega L. Omega is 8 into 10 raised to power 4, and L is 50 into 10 raised to power minus 3. So XL is 4000 ohms, and XC is 1 upon omega C. So XC would be 1 upon 8 into 10 raised to power 4, and C is 2 into 10 raised to power minus 9. So it would be 10 raised to power 5 by 16. So this XC would be 25 by 4 kilo ohms. So Z is equal to 20R. So XL minus XC whole square plus R square is equal to 400R square, and XL minus XC whole square is equal to 399 R square. By solving this equation, we can find out R, which would be 900 by 8. It is a complex equation, so we have to approximately find the value of R. And quality factor is 1 by R under root L by C. So Q would be 8 by 900 under root. L is 50 into 10 raised to the power minus 3. C is 2 into 10 raised to the power minus 9. So Q would be 8 by 900 into 5 into 10 raised to power 3. Okay, so this would be 4000, I guess. 8 into 5, 40, and 40 into 10, 400, and this 400 by 9. So this is 400 by 9, and 400 by 9 is approximately 44 point something, 44.44. So the value of Q factor would be 1. So Q is matched with 1. So correct answer is B. Now we move on the next question. In this question, there is a thin conducting rod Mn of mass 20 gram and length 25 centimeter. The resistance of this rod is 10 ohms and it is held frictionless on this smooth conducting rails, and a magnetic field which is pointing in outside the paper is directed perpendicular to the plane of the arrangement, and this rod is released from rest at t is equal to 0. As it moves down, air drag is negligible. We have to match the correct options. So we have to match the entries at t is equal to 0.2 seconds. So first of all, let us write down the equation of this rod. Now, we know that initially rod was at rest, and at some time t, a force mg would be acting on the rod in downward direction, and magnetic force, which is ILB, would be acting in the opposite direction, and this is equal to ma. Now I would be equal to BLV by R, EMF by R. So mg minus B square L square V by R is equal to M dV by dt. Okay, so dV upon mg minus B square L square V by R integration would be equal to dt by M integration. Limit would be 0 to V and 0 to t. Integration of this term would be ln mg minus B square L square V by R, and limit would be from 0 to V, divided by minus B square L square by R, and that is equal to t by M. So we are applying the limit, then it would be ln 1 minus B square L square V by mgr, and it would be equal to minus B square L square T by mr. So 1 minus B square L square V by mgr is equal to e to the power minus B square L square T by mr, and V would be equal to mgr by B square L square 1 minus e to the power minus B square L square T by mr. Okay, so this is the equation of velocity. Now let us find out the value of mgr by B square L square, and we have to find the EMF. EMF is BLV. So BLV would be equal to mgr by B into L 1 minus e to the power minus B square L square T by mr. Okay, so this is the EMF which we have to find out. So let us find out the EMF, and E is equal to mgr by BL into 1 minus e to the power minus B square L square T by mr. Okay, now we will use this equation on the first page, and we will substitute the value. E is equal to mgr by BL into 1 minus e to the power minus B square L square T by mr. So E will be M, which is 20 into 10 raised to the power minus 3, G is 10, the resistance is 10, and B is 4, and the length of the rod is 1 by 4. Okay, and B square L square T by mr. So B square is 16, L square is 1 upon 16, and T is 0.2 divided by M is 2 into 10 raised to the power minus 3. In fact, minus 2 and R is 10. Okay, so you can see that this value is 1 and hence this value will be, you can see that E would be 2. This value would be 2. And this is not E, in fact, we will multiply. So E would be equal to, this is 2 into 1 minus e to the power minus 1. And e to the power minus 1 is 0.4. So E would be equal to 2 into 1 minus 0.4. So E would be equal to 1.2 volts. So the EMF of the rod, which is option P, would be 1.2. So it is third option. And magnitude of force, so current would be equal to ILB, in fact BLV E by R. So I would be 1.2 by R. R is 10 and I would be 0.12. So current is 0.12 and force will be ILB. So 0.12, L is 1 by 4, B is 4. So force is 0.12. So the correct matching of Q would be 4. So correct answer would be option D. Thank you.